Hello everybody. Let's start. So, thank you all for coming. My name is Philip Baues and I'm a software developer at OMETRO. I started there in May last year and now I'm a tech lead at OMETRO. And today I want to talk to you about React and Reflux and especially about components, actions, stores, and how to handle state and how to not handle state. For this, I've got a very small drilled down example. So I built a very small example web shop, which is just what you can see around here. So I've got a list of articles that are rendered with some information, price, and so on. You can click on them and add them to a basket. So then in the upper right, you will see the basket price or the basket sum being calculated. And if you click on the basket in the top right, basically just the price label, then it will reset the state of the basket. So nothing really special, but it is enough to show the better ways of handling state and how to do that with React and Reflux and what we have with it. Okay, so why React? That is the first question. The good thing about React is it is easy to have a real declarative view abstraction. So we have this basic concept in React of a component. A component is just something that we can render and that we also can nest. So we have this abstraction layer to just have this single purpose components which just do one thing, and that is rendering a special view for the customer. So we can nest them to have one component inside of another, and it's also easy to realize decoupling with React, which means we can just have multiple components side by side, and that is really good for having this decoupling mechanism because we don't influence one component with another component. That is really nice. The other thing that we get from this, of course, is easy testability. So if we have this decoupling and we have independent components, then we can just test them because they're basically just functions. We put something in, we get a rendered result out, and we can test if everything is fine and everything works out as expected. And of course, also for React, the big benefit is fast rendering. So React knows when we change some props, if we change something in the DOM, then it will just re-render that part of the DOM, and we don't have to care about. So it takes a lot out of the responsibilities from the developer on the first side, because we don't have to care too much about making it fast and making it scalable in that way. So that is really good. So what is a component? A React component is just one thing, a single purpose thing, and that is just for rendering stuff that we want to show to the customer or to any page. So it gets in a list of properties, also called props, and also with React, we have this lifecycle mechanism. I won't go into much detail in the lifecycle, that is not what the talk is about, but in general speaking, we have this lifecycle so you can hack in at any point and inject methods or hook into methods that, I don't know, come up if the component did mount, if something happens with the component, and so on. And that is really easy to make it easier to work with that. And of course, we have in React state. So every component has its state, which is, in the first place, not a bad idea because we need state. We need to save some kind of state in our application because we don't want to set it back every time. So the component can directly access and alter the state of itself, so the state of the component. A small example for this. Let me figure out if I can. Okay, I'll just explain it like this. So this is the first example React component that I have. It's just a small component for rendering an article. So I got out all the features and all the lines of code that we don't need for this small example, just to bring it down to what we need. So we're rendering, we get the article in via the props, you can see that, and then we're just rendering stuff that we like. We're rendering the price, the image, name, description, whatever we want to put in there. And that is really easy for decoupling that. So we just get in the properties, and if we also want to test the correct rendering of that component, it's not a problem. We can just test, we put something in, we get something out. Are the tags in there, are the class names used in there? And that is really easy. So this is just a small example. It will get more complex if you use it in the real world, but to show the concept behind it, that's enough. So that is the component of React. So we are not focusing on the life cycle, like I said before, so let's get that out of the equation for now. We don't need that. It will be used on the way, but it's not explicitly necessary for this talk. So the next thing is the state. So the initial idea is in React, you can alter the state directly inside of a component, which means you don't have this single purpose component anymore and not a real separation of concerns, because inside of the component you can access the state, which is fine, and then also alter the state, which is maybe not so good, because then you can't just directly test it and have this decoupling anymore. Because in every component you have to care when you want to test it, in which state is it, how can I manipulate that state and get it to a state so that I can test every case, and that is not so easy and not so nice. So if we get that out of the equation, we're going basically to Reflux. Let me just drink for a second. Okay, so what is Reflux doing here? No, it's dying. Just give me a second. Perfect. Working as expected. So with Reflux we can add stores, and stores is just a concept to handle state. I will get in more detail what a store is, what a component is, and how to differentiate and what to put in where. But basically, in a store, we do all the state handling. We do the logic to when to set the state, if something happens, an action happens, what to do, what not to do. And also, the store is there for propagating the state back to the components. So the store handles it to the components. So we have a really good decoupling, because we have on the one side components, single purpose, rendering one specific thing, and on the other side we have the store just doing the state handling. No rendering, just getting things in, having the state, doing some calculations, state manipulation, setting it again, and giving it back to the components basically. So decoupling is even more easy with that. And the testing part, like I said before, also gets more easy, because we have just those single purpose things and we don't have the state inside of the components anymore, directly altering the state inside of the components anymore. And the very good thing we have here, or we gain through using Reflux in addition to React, is transversal state handling, which means if the state is altered from one component, not directly altered, but through some actions altered from one component, it will get transversally transferred to another component. So the other components know when the state changes, and therefore it is really easy to get this state handling right. Still, there are a few pitfalls which I will come to later. Okay, so the basic data flow of React in combination with Reflux. We have a component, and a component calls an action. Basically, a user clicks on a button, or I don't know, does some filtering, whatever, and then just an action will be called. I'll get into details of the components again, of actions later on. Okay, the action will then execute some method function inside of a store to do the state manipulation. So the store then does the state manipulation based on the input it gets through the action, and then does the state handling and sets the state. So this state can then be propagated back to the components. For that to work, we need the components, of course, to know which store to basically listen to, basically to connect to. So a component can register to connect to one or multiple or zero stores. And of course, the stores need to know what actions they have to listen to, so the dispatcher basically knows where to put them. Okay, so what do we get from there? We have the Reflux component as before, and this is basically just an extension of the React component, because we can do with a Reflux component everything that we can do with a React component, plus the state changing is made more easily, or state handling in general. Okay, so the component additionally can set stores. So the stores they want, or one component wants to connect to, we can add one or multiple, like I said before, as we need it. That way we only have the interaction logic inside of that Reflux component. We don't have any data changing logic. We just have the interaction, user clicks, what should happen next. And that is again adhering to the best practices and things we want to achieve with using React and Reflux. And this is achieved by just treating the state as read-only. But because we don't alter the state anymore, it's making things easier. So we are just giving all the state handling to another component, to the store. Okay, so what are actions? An example will follow later. So actions are basically just functions. It's getting called by any component. So a component will call an action or throw an action, I don't know how you want to call it. And this action will then transport the payload to whoever listens to. Normally, this is just a store, any store, multiple stores, listening to a function, to an action, I'm sorry. Okay, so what are stores? Stores are in this equation then the pure state handler. So they listen to actions that were called by any component before, and then they will do setting and setting state of the components, so setting back the component state and calculating the state based on the action and the current state. So in the stores, we actually store the actual state. Really nice formulation, right? Okay, so in here, it's the only way we can change alter the state. And that is why we only have the data logic in here, basically. So no rendering, no user interaction. It is just we get something in, and we will compute the new state based on what we get in and what we had as a state before. Okay, so an example of how it can look in Reflux, we're just creating a list of actions. Like I said before, for this example, I'm just having one action for loading articles, one action for adding an article to a basket, another one for removing that article, or one specific article again from the basket. And I want to be able to clear the basket, so set it back to its initial state, basically. Okay. So what does a store look like in Reflux? I'm just bringing it down to a very small basic. Sometimes things are missing, but that is just boiled down to the most necessary things. So we're having a Reflux store, which is here the article store. The article store is there for storing the information on the articles. So it will do later on the interaction to load the articles. So in the constructor, you can see we're having this state, this.state. It's fine in here because this is the only part of our software where we really have the state handling. So we're setting it initially to an empty list of articles, and we're listening to a load articles action that I showed before. So when this will be called from the UI, or from our component, we will here listen to that action and then call the function behind that, which is this.load articles. Okay, in load articles, I put out all the reloading of the articles into this article client. I like the concept of, having this single purpose things. We have here the state changing and manipulation, and in the article client, it basically just fetches a list of articles from some endpoint, or here's just some mock data, basically. We're loading the articles. If it goes right, everything is completed, then we'll jump into the load completed, which sets the state. So the articles that are in this store will just be the new articles that we just fetched. And if it's not going right, and if it's failing, we do some kind of error handling here. I'm just logging a warning. Doesn't matter for this example. Okay. Okay. So what is a component? We have also a small example for a component, and then we'll get to what we should do and we shouldn't do for state. Okay, so a component we have here. In the constructor, you can see that we have this .store equals article store. In some older versions of React and so on, it is done, of Reflux, it's done in a different way, but I really like you just set the stores and it will directly connect the state of the store to the state of the component. And you don't have to care anymore about when the store triggers, what to do, what to not do. This is really easy. It's really making things simpler and helps you to not bring in any errors and any problems. So by this, we're just setting the state of the article store in our component. On component did mount, this is the only lifecycle thing I have in here. We're just loading the articles, so triggering the load articles action. Of course, I could have done it with some init, get init state in the store, but just to show how the actions look like inside of that component, I wanted to place it here. And then we have the rendering. And inside that, we are again returning some renderable content. And there we're just mapping through all the articles in the state that we have. So we can access this .state.articles. And that is basically what we had in here in the article store, this .state, and then there's the articles. So we can directly access that by doing the simple this.store equals article store. So this just connects the component with the store, which is really easy. And then we are, as I said before, we have the article class in article component inside of this component of this example web shop component. That is again the nesting of components, which makes it easy to have this decoupling and single purpose things. Okay, so what to not do? I've got a few examples. Of course, it is not an extensive list. I can't cover everything, but just a few errors that I also had on my way and that I want to share with you. So the first thing with state handling that we want to avoid is basically any getter functionality inside of stores. The problem is if we have a getter in a store, we just access it once, get the data out of the store, and the component doesn't know when the state changes. So it won't get any update back from the store, and no state changing is communicated back to the component. So this is not really helpful. Also, we have unnecessary state in components, as I called it. So basically, it is, as I said before, really easy to connect the state of a store back to a component or to multiple stores or to a component. And just because it's easy doesn't mean we should do it all the time. I mean, we can just edit this.store equals something and load in every component, every store that we had before. It will be easy. It will be pretty good readable. But still, we are making it complex because we're having the state connected or the store connected to the component, which we don't need. And that brings me to state versus properties. So when we can do, we should avoid putting all the things into the state and hand it in on a higher level via the properties. I will have some examples for that. Okay, so the first thing, the getters and stores. We are back to a store that I created, a Reflux store. This is the basket store, basically just handling which articles are currently inside of a basket. So as you see above, we have this .basket, and that is what we have before. I'm just using another notation here to show you the difference of another version, basically. Okay, we are listening to the action add to basket, and if that action is called, we are calling inside of the Reflux store the add to basket function. And in the bottom you can see all it's doing, it's just checking if the article is already in the basket, and if it's not, we're adding it to the basket and triggering the state of the store again, basically. But the problematic thing we have in here is the get basket in the middle. So this enables us to directly from the component access the state of a store instead of handling it in via the normal way of the connection we had before. And if we go to the component which is using this, so this is the component, it's again the article as we had it before, basically, and we are just having the article handed in via the properties. But the problem is inside of the onClick function that you see, it's using the basket store.getBasket to find out if the article is already in the basket or not. I'm just using some string to show we would do stuff here. We would call another function or throw an action, whatever. I just want to make it easy here. Okay, and this means we would just access the basket store via basket store get basket, so the state just once. When rendering the component, the component wouldn't know when the state of the store inside of the store would change, and therefore would just render it once. Then we would add another article to the basket, and we wouldn't re-render the component because the component doesn't know that it has to change. It doesn't know when the getter would return another thing. So let's get to the second example, which was unnecessary state in components. Where again in the article, to make it simple, And in the constructor, you can see that we have this dot store equals basket store. Like I said before, it's just a single line. It makes things easy, but because it makes things easy, it's, yeah, well, maybe used a bit too often. So here we are accessing the state of the basket directly over the state, handed in before, which is of course much better than doing that via the getter. That won't really work out. But the problem here is we don't have to do that. Basically, we're having in every article component that we have as a child component inside of this web shop. For every article, we are rendering this, and for everything, we're going through the whole basket of articles and checking if it's already in. We could do it in a more easy way, but in the end, we would do the same thing multiple times, just inside of each child component here. Sorry. Okay, so what could we do here? State versus props. Instead of accessing the state of the store via the connection that we established before, we could instead hand the information in via the properties. So our component now just depends on the input that we get via the properties. And we can do the same thing, this.props.something, and test for the same thing, but instead of having this in the state of the store, we're getting it handed in via props, which makes it more decoupled and easier to test. So how to handle state? If you can avoid it, don't. If you can avoid having state inside of a component, then please don't do it. That makes things just easier to test, easier to decouple, and just better to read. So how to handle state if you have to? That is a maybe harder question. So the idea is to access state from as few components as possible. Like I said, if we spread the access and of the state of a store to many components, that makes things just harder to read, harder to understand, because many things are implicitly happening. And we should not alter, in any case, the state of any store directly from a component. This would break the whole idea and concept of single purpose and separation of concerns, having the store with the state handler and the component as just a renderable component. So that is what we also want to avoid. And we should try to extract state on a high level and handle it to child components via the properties. Like I said before, and also playing back to the first point, don't accessing the state from just wherever, from any component, just because we can. This does not mean that we just extract everything we have as state, basically, and put it inside of the highest parent component and head everything down to every component via properties. This would break our fast rendering, because then if any property changes, everything below the parent component will be re-rendered, and that is also not what we want to achieve here. So if we have to handle state, another possibility is stateless components. Maybe sounds strange, but I will have a quick example for that. So stateless components, I've got an example here, are basically the same as React components, but in a smaller written way. So we're having just this example web shop header. It's just showing the header, and it's just a function basically of the sum price, so the summed up price, and it will directly return something renderable. And down below, we can still use the prop types to define the properties we get handed in, like here, the sum price, and then it knows what to put in there and what we can't put in there. And exporting that is also easy. So what are the benefits of doing it like this? First of all, it's removing some of the boilerplate. We don't have to have the constructor inside. We don't have to define it as a class and define classes over classes over classes for every component. And that just makes things easier to read. It's not much, but a bit. The big benefit of doing it like this, you cannot access this .state and alter the state of the component directly, because it's not a real component anymore. It's just basically a function getting one argument or multiple arguments and returning something renderable, or functional stateless component. So we cannot by accident or by, just because it's easier to just add the state and the component or the connection to a store here, do that. It just encourages us to adhere to the best practices of not doing that connection if we can avoid it. If we have to, of course, I showed you some examples how to do it before, but if we can avoid it, this is a really nice way. And also it makes things more easy to read because we don't have the this dot props and so on, because it's just handed in as an argument in here. So we cannot access this here, and this is also just trying to protect us from doing maybe stupid things. Okay, so this would be my last example. So why are we here, or why is Metro here? So we are building basically some web shop. For the customer, it just looks like a web shop, but what we're actually doing is a whole fulfillment pipeline. So everything that's happening behind the curtains is also done via our applications and our software. So the optimal routes, calculating the optimal routes for the pickers that run through the stores and the depots to fetch the articles, or for example, applications for the drivers to know what articles, what the article of how many depot goods transportation goods we can put inside of a truck, doing that estimation, calculating the best tour. We're having a own depot that is just being built up, completely managed by our software. So it's a whole ecosystem around this for the customer, just plain simple web shop. So it's happening a lot more behind the curtains. That is why we are using React and Reflux at the moment, but we are basically free to choose. And I'll come back to the tech stack on the next and last slide. Okay, so the tech stack at Metro that we have is we're having Docker containers as a base level of abstraction on the bottom. This helps us scaling things up and down really easy, really fast, and also making it independent of each other. That is really a nice way. Up above that, we just have REST APIs. So every Docker container that we have is just has to offer some RESTful API. Looks something like this. So just a normal RESTful API callable via HTTP. And all the Docker containers are orchestrated by Kubernetes. So that is easy for scaling the whole thing up and down. So we have, I don't know, above 200 microservices running at the moment in production, and it's getting more and more every day, sometimes less because we are merging things together again, but normally it's just growing because we want to have those single purpose containers. In the persistence layer, we are mostly using Cassandra, so that is easy to scale things, to have fast access, reading and writing, and that is really nice. So these are basically the only restrictions that we have. So for a developer, it's just we have some Docker container that has to offer some RESTful API, and the rest is free to choose. So every developer can basically check what is the best thing that we could do, what is the best software, the best programming language that we could use for any problem to solve it in a good and in an efficient way. So in most of the containers we have for the front end running React with at the moment JavaScript, but as I said, it's free to choose as long as the team can manage that and maintain that. So we're trying out many different things. In the backend, we are mostly using Java 8. But as I said before, we also have a whole level of other programming languages. So we have, for example, a lot of services in Scala. We have some in Golang. We have some in Clojure. We have some in Haskell. We have some in ClojureScript. And we have also some LaTeX service for just doing, I don't know, PDF generation. This makes things easy because we just have this abstraction layer of having a Docker container with a RESTful API in between. And that is everything the developer has to adhere to. Everything else is free for the developers to choose. And this also gives us the freedom that every developer can try things out, experiment with what is good, what is not good. We're just trying to add, for example, Kafka to our production system to decouple things even more, microservices. And that is really good for just testing it, scaling it up, scaling it down, whatever. Doesn't matter as long as you have a RESTful API, and that's it. Okay, so this would be the end of my talk. Thank you all for being here, and then it would be time for questions.
Hello. Yeah, cool. Thanks, Philip. That was pretty great. I didn't know that Metro is so tech stack, but I said it to you before. And the new rebranding, as I said, also looks more like tech now.
Yeah.
And I don't know, who's using Reflux right now here in the room? A few. Who will afterwards? So because I'm using Redux all the time, of course, but it's pretty tidy. It's really cool. It looks pretty straightforward. So we have in the app, you saw maybe you can ask some questions, but I don't know. It's either not syncing, or you didn't ask some questions, or you didn't find it. I don't know. Is there a question? Ah, cool. Then we will ask the first one. So, yeah, that would be a question I would ask as well. How does Reflux compare to Redux and similar libraries? Or I would also ask, why did you choose Reflux?
So in the beginning, it was just the more major framework or library that we had. And now I think we also have some services running with Redux. I mean, it all has its pros and cons. For example, it's easier in Redux because we have explicitly this immutable state, and that makes it easier to just not change it at all. So like I said, it's just everything has its pros and cons, but I think on some performance level and so on, and in the end, it's working pretty similar. It's different on some levels, but still similar. So you can exchange it, and that will still work. But this, because the concepts in general are the same of the decoupling, easy testability, and so on.
Okay. Yeah, some other questions. If then I can pass the micro as well. If you didn't find the question box there. No question there? Yeah, there's a question.
Cool talk, Philip. If I want to play around with all the things that you've shown, so maybe find the slides of the talk, or maybe the example that you are giving there with a small web shop, is there a way that I could find that?
Thank you for mentioning. I forgot to tell you about that. So we have all of the slides, the LaTeX things, and all the example code that I generated just to show you all of the examples, and the web shop, basic web shop in the end. We have it on our GitHub, on our OMETRO GitHub account, so you can just access it. It's open source, and have a look and see it over there. Also, just one thing I wanted to mention, we also have a booth over here. So if you have to if you want to have more information on what we are doing and how we are doing it, you can just come over. We're also having some basically coding game there, so you can also try to join and win some prizes. Any other questions?
Yeah. Are there any other questions? No? So I have a question. Yeah, there's one question. Why did you choose Reflux over Redux? But we already answered that. But also, for me, it's interesting that I didn't know before that OMETRO is so in tech, of course, and it's using React and all the fancy stuff right there. What services are in React right now? You showed some. You showed the shop. You are just B2B, aren't you, or B2C as well, or yeah?
That's a good question. Okay, so at the moment we're just B2B, and for that we are having the UIs, and that are mostly, or I think all of them are built in React. So we have the UIs for the customers, and we have the UIs for the employees. So the employees working in the store managers, for the pickers on their mobile devices, doing the picking in the stores and everything, and the drivers driving around using the same thing on their mobile devices. And also at the moment we're just serving back to B2B customers, but we are now opening it up to every other customer who has a OMETRO card. So at the moment we have this project running, and it's rolled out in I think 4 or 5 countries now. We are rolling it out even more to up until we have every of the 26 countries live. And in the meantime, we are also developing everything to advance the possibility for the customers to buy and get articles delivered. So if you want to pick it up in the store, if it's coming through some marketplace software that we're integrating with, everything will be added in the future. So that is what we are trying.
Okay,
so good question.
So more or less you write every service in React for the employees and also for the customers.
Like I said before, free for whoever writes it. So we have some services in ClojureScript and so on.
Yeah, cool.
So it doesn't really matter.
Yeah, nice. I saw the store you mentioned, and I always tried during the talk. I tried to compare it to Redux as well, and there are some similarities, but I think it's more tidy because you don't have. I don't want to start some war of Redux and Reflux. So, but I think I work with Redux, so I find it pretty interesting that this store, for example, is a little bit comparable to the reducer or the reducer and selectors. It's something like that, and it's doing the Reflux, the Reflux.component does the connect what is in Redux, isn't it?
Yeah. So before it was also in some older React versions we had this Reflux versions, we had this Reflux.connect, and then you're connecting directly to a store, and this is now implicitly done to this setting of the store into this. And that is just making it easier and simpler to also connect to multiple stores. Okay. But yeah, it's doing that basically under the hood.
Yeah, that's pretty interesting. So as I said, I will try it for sure afterwards. Yeah, you already answered this question as well. You are separating as well into dump and smart components, or stateless and stateful components, or whatever you want to call it. And yeah, you do it in Reflux as well.
Yeah. So as much as we can, trying to have it in separation of concerns, just as properties, arguments, handing over to a dump component, rendering stuff, having the data logic inside of the store, and then we can easily test both of the things and decouple that.
Cool. So that were all my questions. Yeah, cool.
Thanks for the talk. Can I use Reflux in React Native as well, or is it just for web?
I think you can also use it in React Native.
Yeah, is it compatible with React Native components and stuff?
I think
so I'm not sure if you.
I've never done it like this, but I think so.
Okay, cool.
All right, then thanks again and a big applause.